11.7, dilations on the coordinate plane. A dilation is a transformation that enlarges or reduces a figure. Think about dilating your pupils. When you dilate your pupils, they get really big. So you can even try this. If you go in front of the mirror and you turn the lights off, your pupils will get really big. You turn the lights on, your pupils get smaller. They stay the same shape, but they're changing size. Therefore, a dilation is not a congruence transformation. Because if you're going to be congruent, you have to be not only the same shape, but also the same size. When the center of dilation is the origin, you can find the coordinates of the image by multiplying each coordinate by the scale factor. Our scale factor is represented by the letter k. So if they give you x comma y as your coordinate, your dilated figure will be k times x, comma, k times y. Let's try some of them and see what happens. A figure has these vertices. Graph the figure and its image after a dilation with a scale factor of 1/3. So my k is 1/3. Well, we have our original vertices. Let's get our image vertices first before we go to graph. So the rule is you take the original and you multiply by the scale factor. So r was -3, 6. Now it's going to be -3 times 1/3, comma, 6 times 1/3. Multiplying by 1/3 is the same as dividing by 3. -3 times 1/3 is -1. 6 times 1/3, or 6 divided by 3, is 2. S prime would become 3 times 1/3, comma, 12 times 1/3. 3 times 1/3 is 1. 12 times 1/3 is 4. And the last one, t prime, would be 3 times 1/3, comma, 3 times 1/3. Well, 3 times 1/3, or 3 divided by 3, is 1. 3 times 1/3, or 3 divided by 3, is 1. So we have our new vertices. If you look at them, they got much smaller. So let's graph our image first. Actually, let's start with our pre-image. Actually, we don't even need a negative y-axis here, so let's give ourselves plenty of room. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so set up your graph. I'm going to graph r first, -3, 6. Three, 12, and 3, 3. So that triangle is a pretty decent size. Now let's graph these in green. -1, 2, 1, 4, and 1, 1. And just like I predicted, my triangle stayed the same shape, but it got way smaller. Let's try another one. A figure has these vertices. Find the coordinates of the figure with a dilation with a scale factor of 3. So this time my k is 3. So let's come over here and we will write our new coordinates. So I'm going to have -3 times 3, comma, 6 times 3, which gives me -9, comma, 18. The next one, 3 times 3, comma, 0 times 3. I end up with 9, comma, 0. And the last one, 3 times 3, comma, 3 times 3, which gives me 9, comma, 9. So in this case, it looks like my coordinates got way bigger. So let's first graph our original. Looks like the biggest I need to go in the y direction would be 18. Again, I don't have any negative y values. So we'll stay up here, giving ourselves plenty of room. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Again, if you use graph paper tonight, it'll make your life just a little bit easier. You don't have to, but I do recommend either using graph paper or GeoGebra. Okay, let's start with the pre-image. I was at -3, 6. Three, 0, and 3, 3. So again, we have a triangle here. Now we'll go for the green for the image. -9, 18. 9, 0, and 9, 9. And that triangle got way bigger. It got 3 times bigger. So it says, and got at 1, did the figure get bigger or smaller? We'll look back up here. From pink to green, it got smaller. Now note that our K was 1/3. And the last one, got at number 2, from pink to green, it got way bigger. And my K was 3. So what does this mean? Well, if your K is bigger than 1, looks like your figure is going to get bigger. It would be an enlargement. If your K is smaller than 1, it gets smaller. It's a reduction. If your K equals 1, well, multiplying something by 1 doesn't change it, so it would have no change. So let's try one without coordinates. Megan wants to reduce, so you know it has to get smaller, an 8 by 10 inch photo to a 2 by 2.5 inch photo. What is the scale factor of dilation? So if I have this first photo, it's 8 inches by 10 inches. And she wants it to get smaller to become 2 inches by 2.5 inches. They want to know what the scale factor is. Well, we just wrote up above that in order for something to get smaller, my scale factor has to be smaller than 1. My K must be smaller than 1 in order for it to get smaller. So how do I get from 8 to 2? Well, I would divide by 4. Is that the same thing to get from 10 to 2.5? Do I divide by 4? Yeah, you do. Well, another way I could write this is I could compare 2 to 8 because they are in the same position. We learned this back in chapter 5. 2 to 8, they're in the same position. That reduces to 1/4. I could say the image is 1/4 the size of the original. My K, therefore, is 1/4. If you wanted to remember it this way, your K is always going to be your final number over the original, which you may remember that from chapter 5 as well. Final over the original. So my K is 1/4. Now if I was going the other way around, it would end up as 8/2 or 4. We know that if your K is bigger than 1, you would get bigger. And moving from the 2 by 2.5 to 8 by 10 would get bigger, so that makes sense. So I would always check my answer and say, does it make sense? Did it get smaller or is it getting bigger? And compare it back to what you know to be true. That in order for something to get bigger, it has to be bigger than 1. And in order for something to get smaller, it has to be smaller than 1. All right, that's the end of section 7. You have your homework to do. Like I said, I would suggest doing it on graph paper or GeoGebra just to